This is the objective related to the percentage yield of the various products during the halogenation of an alkane. And here it is fluorination. It's given that when fluorine reacts with 2-methylpropane in presence of light, we get two different products. One is tertiary butyl fluoride, which is 14%, and isobutyl fluoride, which is of 86%. And we need to find out the relative reactivity of tertiary hydrogen to that of the primary hydrogen. From the question itself, it is clear that the reactivity of the primary, secondary, and tertiary hydrogens towards the halogenation is different. And the alkane given here is 2-methylpropane, and its structure is like this. And this compound has the primary carbons, these three, as well as a tertiary carbon. So that is the reason why I can write as the number of primary hydrogens as equal to 9 and the number of tertiary hydrogens as equal to 1, because these three are the primary carbons and the corresponding hydrogens become the primary hydrogens, and this is the tertiary carbon and this becomes the tertiary hydrogen. So here let me take the relative reactivity of tertiary hydrogen as equal to X and that of the primary hydrogen as Y. Now tell me how to get the relative amount of the various products formed. See here. First let us write down the product formed by the replacement of one of the primary hydrogen with fluorine. What we get? We get this compound isobutyl fluoride, isn't it? The relative amount of isobutyl fluoride is nothing but equal to number of primary hydrogens, that is equal to 9, multiplied by its relative reactivity, that is Y. Then what will be the relative amount of the second product, that is the tertiary butyl fluoride, which is formed by replacement of the tertiary hydrogen with fluorine. This is equal to the number of tertiary hydrogens, that is 1, multiplied by its relative reactivity, that is X. Then the total amount of both these products is nothing but 9Y plus X. So once you know the relative amounts as well as the total amount, definitely we can calculate the percentage of that particular compound. So the percentage of isobutyl fluoride is nothing but equal to 9Y upon the total amount, that is 9Y plus X, multiplied by 100, which is given as equal to 86. Isn't it? Solve this. 900Y equal to 774Y plus 86X. Bring this one to this side. We get 126Y as equal to 86X. And X by Y is equal to 126 by 86, which is nothing but equal to 1.465. Here we just require the relative reactivity of the tertiary hydrogen to that of the primary hydrogen. That is X is to Y ratio we need to calculate, and that we got it as 1.465. And that is there in option A.